Okay, so we're going to work with just this worksheet today. It's 18 problems, but these problems take some time. So we're going to do a few of them together here, give you a little idea as to what we're going to be doing, and then we'll kind of get into back to normal notes next class period. So there's this formula called the quadratic formula. You may have learned it in Algebra 1, or you may not have. And it's this formula here. So it might look familiar to you. It's on the formula sheet also, but it's x is equal to negative b plus or minus the square root of b squared minus 4ac, that whole thing divided by 2a. And those a, b, and c values are just your a, b, and c from your standard form quadratic. So the idea with all these problems are we can take our a, b, and our c values, substitute them into here, simplify this, which is the tough part, and that's actually going to give us our solutions to a quadratic. And we'll get to the notes and talk a lot more about that when we get to like the actual note packet. But this is really today's skill is, can you simplify these correctly? Because there's a lot of little kind of funky things that can happen. So we're going to start with a pretty basic one. So this very first one, we'll do about 4 of these together today. So this first one is actually what I would call a pretty easy example. So like in this case, our a value is 1, our b is -5, and our c is -14. So I'm going to just rewrite this formula with those numbers substituted in. Okay, so it's negative b. So it's going to be the opposite of this. So it's going to be actually just +5 plus or minus. And then it's b squared. So that's going to be -5 squared minus 4. My a is 1 and my c is -14. Okay, and that whole thing is over to a, and my a is 1. So that's kind of step one. So we get everything written out. Yeah, it's a little bit messy, and that's fine. And then from here, we're going to simplify this, which is why we've spent the last couple, last lesson, learning how to simplify radicals. Today's warm up talking about this should all kind of lead together. So we really need to simplify what's under this root first. So we're going to have 5 plus or minus. It's going to be over just 2 times 1, which is just 2. But it's under this root that we really got to work things out. So let's figure out what we have. -5 squared is going to be 25. And then the -4 times 1, obviously that's just -4. But the -4 times -14 is going to be plus 56. Okay, so what do we have? That actually just adds up to 81. So we have 5 plus or minus the square root of 81 over 2. And the reason why this one ends up being pretty nice, I'm just going to kind of continue my work up here, is 81 is a perfect square. So this is really just 5 plus or minus 9 over 2. So I've simplified this down really far now to the point where I can give my answers. And again, the reason why I say answers is you're going to do this problem once where you add, figure out what it is. Then you do this problem once where you subtract and figure out what it is. So now I'm ready to do that. So when I add and I do 5 plus 9, that's 14 over 2, which 14 divided by 2 is just 7. So 7 is going to be one of my solutions. My other solution is what happens when I subtract. 5 minus 9 is a -4 over 2. -4 over 2 is -2. And so I get that my two solutions are 7 and -2. That's one that doesn't work out too bad. What happens, it's really based on how difficult is this root. If it's a perfect square, this problem's not bad. Yes, it takes a good chunk of steps, and you want to make sure you got those down. But overall, not terrible. The next one I wanted to look at here, let me see what I circle on these. Sorry. Oh, it was number 7 down here. So let's go ahead and look at 7. So it's going to be, all these problems are the same process. You're doing quadratic formula on every one of them. And so that's what we really got to get into. So we're going to go, it's always -b. So in this case, it's going to be -8 plus or minus the square root b squared minus 4a. Oh, sorry. I'm dumb. Although it's fine. I haven't done anything wrong yet. The reason I picked this one was I wanted to point out that it needs to be in standard form, meaning we need to get this set equal to 0. So we need to subtract this 4 over. So this is going to be 0. This is actually going to be a plus 3. So my a and my b haven't changed, but my c does need to be 3. So sorry, when I get to here, I got my b squared minus my 4ac. My c needs to be 3. So again, definitely should do that ahead of time. Get the equation into standard form. So if there's anything on one side, like you're going to see in this one, like you're going to see over here, you want to move everything to one side of the equation so it's in standard form. Okay, so anyway, I still need to go over to a, so 2 times 4. Okay, cool. So this is what I'm looking at. Let's get to simplifying. So -8 plus or minus, what's under my root? 8 squared is 64. 4 times 4 is going to be 16. Times 3 is going to be 48. Okay, and then 2 times 4 is 8. All right, not too bad. So we get negative 8 plus or minus. This is going to be 64 minus 48, which is 16. So another one that's a perfect square. It's a good sign. And in this case, that's going to be just 4. So again, I'm going to kind of move my work up here. So I'm going to have negative 8 plus or minus 4 over 8. Now I picked this problem because your solutions end up being fractions. I just want to show you like that's perfectly fine. You're going to get fractions sometimes. So now that I've got this simplified pretty nicely, I'm going to have negative 8 plus 4. So negative 8 plus 4 would be a negative 4 over 8. And that's going to reduce to negative 1/2. So negative 1/2 is one of my solutions. My other solution is going to be when I subtract. So negative 8 minus 4 is going to give you negative 12 over 8. Reduce that fraction. That's going to be a negative 3/2. So once again, we get two solutions. And you pretty much always expect two solutions. The only time you're not going to get two solutions is if you get a 0 here. I think there's like one of these on here where that happens, where you get a 0, in which case your plus and minus, you're going to get the same thing. So you'll see that on one of the problems when you get to it today. Okay, so those are both pretty normalish problems where you get roots that work out nicely and there's nothing too crazy going on there. Now, let's go ahead and look at the back side here. Let's jump to like number, let's see. Let's talk 12 real quick. So 12, we've got one we need to get into standard form. So you move this to standard form, it's just going to be subtracting the 80 over. So it's going to be like 5r squared minus 80 equals 0. I picked this one because I wanted to point out that sometimes you don't have a certain value. So like my a value is 5, but there's no r term. So my b is actually 0 when I go to do this problem. Okay, and then my c is going to be the negative 80. Okay, again, look, if you're missing a term, in this case, you're missing that middle, that r term. So you got to pay attention to that, and you got to use the right value. So just so we can work it out, this one actually works out really easily because b is 0. Because you're going to have 0, or negative 0, but same thing, plus or minus the square root of 0 squared minus 4 times a times c all over 2a. And the reason why b0 works out really nicely is things just simplify out pretty good. So in this case, you're just going to do, 0, and then negative 4 times 5 is going to be negative 20, and negative 20 times negative 80 is going to be plus 1600 all over 10. So running out of space, let's go ahead and move up here. So under my root there, it's just going to be square root 1600. So I have 0 plus or minus the square root of 1600 over 10. And 1600 is a perfect square, and if you don't know that, since 16 is, it makes sense that 1600 is, but you can see here, it's just 40. So we get 0 plus or minus 40 over 10. So now we're ready to get our two solutions. 0 plus 40 is 40, divided by 10 is 4. And 0 minus 40 is negative 40, divided by 10 is negative 4. And so again, we can get our two solutions from there. Okay, the last piece I want to look at here, and you're not going to see too many of these. Actually, just to give you a heads up, there are 4 total. So after we do this one, there's going to be 3 of them. But there are some problems that come out to roots that you're going to have some trouble simplifying. So let's go ahead and look at 16. So 16, again, we need it in standard form. So this is going to be 9n squared minus the 7n minus the 4 equal to 0. So again, moving those over to get it into standard form. And now let's go ahead and put my a, b, and c into quadratic formula. So it's the opposite of b. So that's going to be 7 plus or minus my b squared minus 4 ac all over 2a. So 2 times 9. All right, so we got a lot going on here. Let's see what we work out to. So 7 plus or minus. Under my root, I'm going to have 49. And this is going to become a plus. So we got 4 times the 9, or negative 4 times the 9. And then times the negative 4. So that's going to be 144. And then on the bottom, 2 times 9 is 18. Okay, go ahead and bring it up. It's running out of space. So I've got 7 plus or minus the root of 144 plus 49 is 193, which is kind of a funky number. And the reason I say that is 193 is one of these where you got to see, does it have any perfect squares? And you should remember doing this from the other day. But, if you're trying perfect squares and you're like, well, okay, 4 doesn't go into it. 9 doesn't. 16 doesn't. 25, oops, helps if you type it in right. 25, no go. And what you're going to find here as you go through and you exhaust kind of all your perfect squares, there are none of them that are going to go into it. Now, there is no awesome method for this other than literally what I'm doing right now, which is trying to find a perfect square that goes into it. Eventually, once you go high enough, I know nothing else is going to work because 2 times nothing else is going to go, so I don't need to keep going. But at this point, there were no perfect squares that go into it. So that means that I can't simplify this any further. So you can do one of 2 things. You can actually leave your answer like this, and basically this is saying, hey, there's 2 answers here. I can't reduce anything any further. There's nothing that can be divided. Sometimes you'll see on the key for this, they split it up into the 2 solutions. So they'll write it as you have the plus solution, and then you have the negative solution, basically saying, hey, these are the 2 solutions. Both ways are okay. And when we get to the point where we're doing these assignments on the Savas site and stuff, it'll take either of these, where you're either listing it like this with a plus or minus, or you're listing the 2 different ones. So these are the ones that you get some of these that are a little bit messy. Like I said, there's only, 3 more of these left on the sheets altogether. Everything else will come out to either whole numbers or fractions, but there should be 3 more that have roots that you can't simplify. Again, you'll have the key for you so you can kind of check them as you're going. But this is the big skill today is, can you simplify this quadratic formula? And again, that formula, if I didn't put it away, is on the formula sheet. It's also right here, so if you need it, boom, there it is, nice and big. Or obviously you can just Google quadratic formula. It's kind of one of the most important formulas in Algebra 2. We're gonna use it a lot. So it's going to kind of spend a full day where you're going to practice it, see if you can go through and do these. You really want to be able to get all these right. So if you're running into trouble, if you feel like you're doing something and everything's just not working, hop into the help session, send me an email, comment, whatever, if you need some help on something. So let me know how it goes.